right, ladies and gentlemen, so today we're going to be working on something called scientific notation. And again, down here is where we have this beautiful thing where it kind of describes it. But basically, scientific notation is a way to write really big or really small numbers. And what's happening is that it always has a certain form, and that certain form is right here. So it's always d, which is representing some number, times 10 to an exponent. The d, there's certain rules. D has to be between 1 and 10. It cannot be bigger than 10. It can be 9.999999999, but it cannot be 10. All right, so the way this works is that down here you'll see all different numbers written. Let me move it up. You'll see all different kinds of numbers written in scientific form, but only one of them is correct. So here was my number, 234.567. Well, in order for it to be in scientific notation, these are all equal to that. But only one of them is in correct scientific notation, and that's this one. And the reason is because the number out front is between 1 and 10, and then the exponent is right. If I look at this one, this number is too big, right? Too big. If I look at this one, it's too small, too big, too big, too big. Okay, so they have to fit into that, part. Oh, that's not so good, is it? Okay, remember, scientific notation has three parts. It has a number out front. It has a base of 10, and then it has an exponent. Okay, so are the following numbers written in scientific notation? Explain why or why not. So that's what I'm looking for, is the number out front between 1 and 10, and is it, you know what? I'm going to put this. I'm going to change this, go back and change it. It's going to have a times sign, and then it's going to have 10 to some exponent n. All right, so let's take a look here. So exercise 1, is this written in scientific notation? Yes. This number is between 1 and 10 times 10 to some exponent. For exercise number 2, this is not written in scientific notation because 0.325 is too small. I have, for exercise 3, 7.99 times 10 to the 32. This is yes, that's correct scientific notation. For exercise number 4, this is no, because it has a plus sign, not a times sign. For number 5, this is no, because 18 is too big. And number 6 is yes, that is correct scientific notation. All right, so let's take a look over here. So use the table below, shows the debt of the 3 most populous states and the 3 least populous states. What is the sum of the debts of the 3 most populous states? So let's see. The population, the 3 most, so we're looking at these 3. So the first thing I have to do is to add those numbers together. So I'm just going to deal with the 407, the 337, and the 276, and then I'll put the zeros on at the end. So 14, 20, carry the 2, 10, 12, 7, 8, 9. And then if I put my zeros on, there were 9 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so to get this number into scientific notation, we're going to move the decimal point. And to move that decimal point, we're going to move it from the end to in between the first 2 numbers, because that's going to allow the number to be between 1 and 10. So this is going to become 1.02. You drop all those extra zeros. Times 10, and the exponent is how many places I move that decimal point. So we went 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 places. All right, so the debt of the 3 most populous states is 1.02 times 10 to the 12. Correct scientific notation. What is the sum of the debt of the three least populous states? So that's going to be these three. So again, I'm going to add those together, the 4, the 4, the 2, that's going to be 10. And then we have our 9 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this time, I'm going to move my decimal point from the end to in between, 1.0. You drop all the extras, times 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, to the 10th power. All right, so being able to recognize numbers in scientific notation. Let's see. How much larger is the combined debt of the three most populous states than that of the three least populous states? Express your answer in scientific notation. So I'm going to go back over here, and I had 102 and then 10 zeros. It'd be easier if I could write it down here. You know what I am? I'm going to put C here. So I had the 102, O, and then this was, trying to think here, like this, 1010, and then if I put that into, remember we still had all those zeros, so I just subtracted the numbers out front before I had put them in scientific notation with all those extra zeros. So now when I move this over here, we're going to have 1.01 times 10 to the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 to the 12th power. So that was letter C. And then for exercise number 8, all planets revolve around the sun in elliptical orbits. Uranus' furthest distance from the sun is approximately 3.0 times 10 to the 9th, and its closest distance is that. Using this information, what is the average distance of Uranus from the sun? So average means that we have to add them together and divide by 2. So we're going to do, I'm going to take just the numbers out front and keep the times 10 to the 9th. So 3.004 plus 2.749. Add those together. Then I have to divide that by 2. So 2 goes into 5 2 times, 7, 8, 7, 6, 5, and then we're going to add in our 10 to the 9th. All right, so we also reviewed there a little bit of how to do averages as well. So then we're going to get into our practice. So again, numbers written in scientific notation have to have 3 parts. They have to have a number between 1 and 10. They have to have the time sign. And then they have to have times 10 to some exponent. Any questions? As always, bring them to class. Have a good night.